I'm Anil Kumar. Welcome to my YouTube channel and the website Global Math Institute. Let me thank all the viewers and subscribers for watching my videos, posting excellent remarks and sharing some brilliant questions. Now here's a request from one of our subscribers who wants to understand differences between rhombus and kite. So in this video, to explain the whole concept, we'll take up properties of rhombus, we'll also take up properties of kite, and then figure out the differences between rhombus and kite. To begin with, let us sketch a rhombus. So in a rhombus, all four sides are equal, right? So we could actually draw something like this, kind of like this, right? So all these four sides are equal, so that will be a rhombus. When we're talking about a kite, it may look like a rhombus, but it is actually not. In kite, two adjacent sides are equal and the other two are equal, right? So the other two could be longer. So with these two diagrams, you can easily figure out the differences. So we'll talk about them in details, but let's try to understand. So both are quadrilaterals, right? So that's why the topic quadrilaterals, four-sided figures, right? So let me write down similarities. So both are that means four-side polygon. Correct. So that is kind of important to understand to begin with. So let's talk about rhombus first. So in case of rhombus, let's write down here rhombus and then we'll write and that is for kite. So first I'll illustrate some basic features of rhombus and kite, and then we'll talk about the differences. So as you can see in the rhombus, it is a parallelogram, right? So we do have opposite sides which are parallel. That is one thing very clear. Another important thing here is that these sides are also equal. So all sides are equal. All sides are equal. In case of kite, we have two sets of equal sides, right? So adjacent sides, these are, you can also call them disjoint adjacent sides. So which sides are equal? Disjoint So when we say disjoint, it means that this one is joint, right? And this one is joint. So these two are equal, correct? Now here, all these are joint, right? So all joint equal sides are there. So in a rhombus, what you notice is that we have four equal sides, and that basically means that if I draw a diagonal, right? So if I draw a diagonal, then these diagonals will bisect. So these diagonals will actually bisect in such a way that these sides are equal. Okay. So they actually bisect one another. However, in case of a kite, when I draw these diagonals, in that case, we find that the diagonals are not both equal, but they do bisect one side, right bisect. So here we notice that one is a major diagonal and one is a smaller diagonal, correct? So this diagonal, this diagonal is a major diagonal, a longer one, and this diagonal is also axis of symmetry for the diagram, right? So we can also call this as our axis of symmetry. The longer diagonal. You will notice that for the longer diagonal, it bisects the angles here. But the angles are not bisected by the shorter one. Correct. So the axis of symmetry bisects the angles at the vertex. So you can see how the diagonals are related. They do meet at a right angle, as we are seeing here. However, only one side is bisected. Here both the sides are bisected, as shown here. Correct? Now I hope you got fairly good idea about both the shapes. I'd like you to take a moment and then answer these questions. We'll also now describe the properties of these quadrilaterals and then list all the differences between rhombus and kite. So let me first take the case for rhombus. So again, let me sketch rhombus once again. So we'll sketch a rhombus here and then describe it. So it has four sides. It's a quadrilateral. All four sides are equal and it is also a parallelogram. So this is not all that good diagram. However, we'll make it like this so that you understand. So as far as rhombus is concerned, we can list the properties as it has four equal sides. Correct. It is a parallelogram. Right. So that means the opposite sides are parallel. Correct. Now, when we say it is a parallelogram, then with that we can write the associated properties, and that is sum of adjacent angles 180. So what I'm trying to say here is that if these are my angles, let's say these are the different angles, right? Let's number these angles as 1, 2, 3, 4. So in that case, sum of 1, 2 or 2, 3 or 3, 4 or 1, 4 will be 180 degrees, correct? So sum of the adjacent angles is 180 degrees. Now let's talk about the rotation. Now if I rotate this, it has actually two axes of symmetry. So let's write down axis of symmetry. It has two axes of symmetry. So that means this vertical line, if I draw, that is one axis of symmetry, right? The other one is right there. So these are the two axes of symmetries, correct? So both the diagonals, which are your diagonals. Order of rotation is 2. Is 2. That means if I rotate it, then twice while it goes through a rotation of 360 degrees, it will overlap, right? So the order of rotation here is 2. And then let's talk about the diagonals, right? So diagonals are equal. Or right bisectors. Correct. So when I say the diagonals are right bisectors, that means this angle is 90 degrees and these diagonals are equal. Perfect. So that is how the rhombus looks like. So I hope these properties of rhombus are absolutely clear, right? Now let's take the properties of the kite. So let me sketch the kite once again here. So we are sketching it the same orientation as we did the rhombus, and you can clearly see that one pair is much longer than the other. And as we saw, if these are the two diagonals, right, they do intersect at 90 degrees. However, both are not divided equally, correct? So listing these properties, we can say property number 1, it has 4 sides. Two adjacent sides. So these two are equal and these two are equal, right? Not all 4 are equal. So that is kind of, so we sometimes say consecutive sides. So when we talk about these two sides, we refer to the words as consecutive sides. And we also refer to disjoint pair. So these terms are used in different parts of the world. So that's why I've kind of included them here. Now you can see very clearly that diagonals of different length so the longer one is, we can say, actually divides the figure symmetrically. So we can say the longer diameter, longer diagonal is axis of symmetry. So these some properties of a diagonal are very important here. One is that the longer diagonal is axis of symmetry. And then what you also notice here is that the axis divides angles at vertex or bisects, right? So we say axis divides angles at vertex equally. Right. So it is basically bisects the vertex angles. Now, you will notice that the third property, let me add here itself. Axis is right bisector of shorter or the other diagonal. So these two sides are equal. So that is what we are trying to say, right? Correct. And you will also notice that these angles are not equal. So this angle is equal to that angle, that is fine. Now this angle is equal to this angle, yes, that is okay. But these angles are not equal, right? So that is kind of important to understand. However, the sides are equal, right? So these two sides are equal. Now let's talk about the rotational symmetry. So it does not have rotational symmetry, right? So if I rotate it within 360 degrees, it does not actually match its own position, right? So no rotational symmetry. The order of symmetry is 1. Is 1. Okay. Because after rotating full round of 360, it matches, which every polygon, which every figure will do. So these are your major characteristics for a kite. Perfect. Now, based on this, you can summarize the differences between both kite and rhombus, right? So let's write down now the differences between rhombus and kite. So 4 equal sides. So it has 2 pairs of equal sides. Then as far as the diagonals are concerned, rotational symmetry, let's talk about. It has got 2 is rotation symmetry of 1, and we'll say order of symmetry is 2, right? So let's write it there. Rotational rotation symmetry. When we say rotational symmetry, then we're talking about rotation which is less than 360 degrees. So let me write down here. So less than 360 degrees. Is 1. And here no rotation symmetry. Now there is a lot of confusion about the term rotation symmetry. Watch my video to understand this part, correct? Now let's talk about order of rotation symmetry. So order of rotational symmetry is 2. Here order of rotational symmetry is 1. Okay. So when we say order, we are actually rotating one full circle, so greater than equal to 360 degrees. So when you do greater than equal to 360 degrees, so after 360 degrees, it will match. Every figure will match, correct? So that is how it is. Now we'll talk about the diagonals. Diagonals of equal length, diagonals unequal, so they are right bisector. right bisectors. Now in this case, so about the diagonals, longer diagonal, we can call it, we'll say longer diagonal, is right bisector of the shorter. Right, so that way, so we can clearly distinguish between these two things, right? Now we can talk about line of symmetry. So when we're talking about rhombus, it has got two lines of symmetry. In this case, there's only one line of symmetry. And that line of symmetry is the longer diagonal. So this one is the longer diagonal. Now this is both the diagonals. So along longer diagonal, and this is along the diagonal. Perfect. So that is how you can actually write the differences between the two shapes. Perfect. So I hope that makes sense. Feel free to write your comment, share your views, and if you like and subscribe to my videos, that'd be great. Thanks for your time and all the best.